Welcome back to the BlockSmith Guild, the podcast where we explore how cybersecurity practices are evolving in real time. I'm Michel Combes.
And I'm Morgan Rivera. Today we're diving into something that's been making waves in developer communities, this idea that we're entering a completely new programming paradigm. Michel, you've been experimenting with what some people call vibe coding or AI-assisted development, but you're arguing it's way more rigorous than people think.
Exactly. And I hate that term vibe coding because it makes it sound casual or lazy. What we're actually seeing is a fundamental shift from syntax-first to intent-first development. It's not easier, it's different, and in many ways, harder.
Okay, break that down for us. What do you mean by intent-first development? Think about how we traditionally write code. You have an idea, then you immediately start translating that idea into JavaScript syntax or Python or whatever. You're simultaneously juggling the logic you want, the implementation details, and the specific language constraints. Your brain is doing 3 jobs at once.
Right, and that's just normal programming. That's what we do.
Exactly. But with AI in the mix, we can separate those concerns. I now write behavioral specifications first. Essentially, pseudocode or plain English descriptions of what the system should do. Then I use AI as a transpiler to convert those specs into target languages. The specification becomes my source of truth, not the generated code.
That sounds like it could get messy fast. How do you maintain control over what's actually being built?
That's the key insight. This approach actually requires more discipline, not less. When you write code directly, you can muddle through with fuzzy thinking because the compiler catches syntax errors and runtime reveals logic problems. But when natural language becomes your spec layer, imprecision in thinking translates directly to imprecision in output.
Give me a concrete example. Walk me through how this works in practice.
Sure. Let's say I'm building user authentication. Instead of jumping straight into writing functions, I start with a behavioral specification. The authentication system must validate user credentials against encrypted storage, return session tokens for valid users, and log all authentication attempts with timestamps. Failed attempts must increment a counter that triggers account lockdown after 5 failures within a 1-hour window.
Okay, that's pretty detailed.
It has to be. That's the discipline part. Notice how I'm defining the complete behavioral contract without mentioning specific encryption algorithms, database schemas, or even programming languages. This becomes my North Star for both AI code generation and verifying the results.
But how do you know the AI actually implemented what you specified? Isn't there a risk of it just making stuff up?
Absolutely. That's why I call these specification bugs, a new category of issues where the generated code perfectly matches your description, but your description fails to capture your true requirements. You're now debugging 2 layers, the generated code and the specification that created it.
That sounds like it could be a nightmare to debug.
It's different. Instead of stepping through code line by line, you iterate between specification refinement and output verification. When something's wrong, you first figure out if it's unclear specs or AI misinterpretation. Then you refine and regenerate.
Let's talk about the skills this requires. What does a developer need to learn to be effective in this paradigm?
The biggest shift is learning to write what I call AI-readable specifications. They need to be simultaneously human-readable and precise enough for AI interpretation. This means being exhaustively detailed in ways that feel redundant to humans.
What do you mean by exhaustively detailed?
Instead of saying, validate the email address, you specify, validate that the email contains exactly 1 @ symbol, has at least 1 character before the @ has a domain part with at least 1 dot, and matches standard email regex patterns.
You can't rely on AI to fill in obvious gaps the way a human colleague would. That's a lot of upfront work. Is it actually worth it compared to just writing the code yourself?
That's the million-dollar question. For simple scripts, probably not. But for complex systems, absolutely. The payoff comes from being able to generate implementations across multiple target languages from the same behavioral spec. I can take that authentication specification and generate Go, JavaScript, Python, and Rust implementations that all behave identically.
Okay, but let's get practical. What happens when you're working on a team? How do you collaborate when your source code is essentially English prose?
You need version control for specifications just like traditional code. When you modify a behavioral model, you need to understand how those changes propagate through dependent implementations. Teams need to establish style guides for specification writing, just like they do for code.
Style guides for English? That sounds intense.
It is. But think about it. We already have style guides for code. ESLint, Prettier, team conventions about naming and structure. This is the same concept applied to the specification layer. You need consistent terminology, clear boundaries between components, testable acceptance criteria.
Let's talk about the elephant in the room. Are we still programmers if we're not writing code?
I get this question a lot. Look, you still need to read and verify the generated implementations. You still need to understand systems architecture, database design, API contracts. But the emphasis shifts from code writing to code comprehension and system design.
So it's more like being an architect than a craftsperson?
Exactly. The most valuable skills become domain modeling, requirement analysis, and system architecture. You need to understand how to decompose complex problems into well-specified components that AI can implement reliably.
What about the learning curve? If someone's been coding traditionally for years, how hard is it to make this transition?
It's not trivial. Experienced developers often struggle because they're used to thinking in implementation details. You have to retrain yourself to think behaviorally first. It's like learning to design before you build, which honestly, we should have been doing all along.
Are there downsides? Things you miss about traditional coding?
The immediate feedback loop is different. With traditional coding, you write a function and test it immediately. With specification-driven development, there's more upfront investment before you see work in code. Some developers find that less satisfying.
What about performance? Can AI-generated code compete with hand-optimized implementations?
For most applications, it's good enough. And remember, you can always drop down to traditional coding for performance-critical sections. The specification layer gives you a clear contract to implement against. You're not abandoning traditional skills, you're augmenting them.
Looking forward, where do you see this going? Is this just a temporary phase while AI gets better, or a permanent shift?
I think it's permanent, but it will evolve. As AI systems get better at understanding context and handling ambiguity, the specification requirements might become less rigid. But the fundamental insight that natural language can be a programming interface, that's not going away.
What would you tell developers who are skeptical about this whole approach?
Start small. Pick a side project and try writing behavioral specifications before touching code. See how it changes your thinking about problem decomposition. You don't have to abandon traditional development. Think of this as another tool in your toolkit.
Any final thoughts for our listeners?
The future of programming isn't about eliminating rigorous thinking. It's about redirecting that rigor toward the interface between human intent and machine implementation. And in that interface, precision has never been more important.
Michel, thanks for walking us through this. Fascinating stuff.
Thanks for having me, Morgan.
That's all for this episode of the BlockSmith Podcast. If you're experimenting with AI-assisted development, we'd love to hear about your experiences. Hit us up on Twitter @MGCombes or drop us an email.
And if you enjoyed this episode, please subscribe and leave us a review. It really helps other developers find the show.
Until next time, keep coding, however you choose to do it.